Okay, Chapter 8, Day 3. What we're going to focus on today is what are the re-expression properties of logs. When we re-express something, it means to take it, put it into a different form, but it's still equivalent, okay? So there's three basic properties that you need to know. And the question we usually say something about, if this is re-expressed, what is its equivalent form? Or we use re-expression later on to solve equations. But we can express things in logs using these properties in different forms. So we have three re-expression properties. We have the multiplication property, which says the log of a product, okay, is equal to the sum of the individual logs of those two items. All right? And it doesn't matter what the base is. You can have any base here. So whatever the base is here, these bases are the same. But the log of a product equals the sum of those two independent logs. Okay? So a product goes to plus. A log of a division, and again, it doesn't matter what the base is, as long as the bases will be the same. The log of a division turns into minus, and so it's the top minus the bottom. All right, so the log of a division can be rewritten as, or re-expressed as, the log of the top thing minus the log of the bottom thing. It's just re-expressing it. They're equivalent, it's just a way to re-express them. And the last we have is power. Okay, so if we have the log of, and again, the base is still down here. The base still might be some value. But if I have the log of something raised to a power, then that power comes out front and turns into a multiplier. Okay? So multiplication turns to addition, division turns to subtraction, raising it to a power turns to multiplication, where we multiply out front of whatever the log of that is. Okay. So, for example, the questions might say, re-express the following. All right, so let's take a look at some of these. All right, so let's say this base, I'll make a base of 4 here. It doesn't matter what the base is. Now, I see multiplication and I see power. The power is on this entire thing. So the power is going to be on this entire piece. Okay? So power comes out front. Log base 4, multiplication turns to addition. So I have log base 4 of x plus log base 4 of y. And that's how you would re-express that. Your rule, power comes out front, and the power's on this whole thing, so the power's on the whole thing. Log base 4 of x plus log base 4 of y. Now the power is only on the x. It's still multiplication here, okay? But the power is only on the x, so that will be 2 log x plus log y. In this case, the power is only on the x part, so that's why the power only is on the x part. Multiplication still turns to addition. What do we have here? We have a division with a multiplication on the bottom. Division turns to subtraction, so the log of the top part minus this whole thing. So I'm going to put this in parentheses. Log of 2 plus log b. So the top part minus the whole bottom part, then I need in parentheses. All right? again, if I don't see a base, it's implied base 10. If I write a base, then that same base has to be written in the answer. Let's look at this last one. We got a lot going on. We have a power on the x, we have a power on the y, we have division, and we have multiplication with a base 5. So no matter what log we put in, we got to make sure we do base 5. So I'm going to do the top part. So the 2 comes out front, so 2 log x, that's the top. And my base is 5, so I got to make sure I put my base in there. Minus, the division sign gives us a minus, parentheses, because I've got a bunch of stuff on the bottom. 3 comes out front, because that's a power. So 3 log base 5, got to keep the same base, y, plus log base 5 of z. And so that's how that would be re-expressed. So again, multiplication turns to addition, division turns to subtraction, power turns to product. We can work backwards. So I might start with something and I want to work backwards. Okay, I can work backwards to get to what we started from. So plus must have came from multiplication. So in this case, this would be log base 9, I keep the same base, of 3 times 7. Well, I'm not going to write 3 times 7, I'm going to write it as log base 9 of 21. So log base 9 of 21 is the same as log base 9 of 3 plus log base 9 of 7. You can rewrite it. Over here we got plus, which is multiplication, minus, which is division, and this is all in parentheses, so that has to stay on the top. So I have the log of, and I only write the word log once when I'm going backwards. Notice when I went forward, log was only written once, and then all of this was separated out, and each thing got a log with it. When I'm working backwards, each thing starts with a log, but I'm only going to write log once. My base is 10, so I'm not going to write it. Okay, what am I taking the log of? Well, 4 plus turns to times, so that's 4 times 5 on the top, divided by 2 on the bottom. So that's going to be equal to log, 4 times 5 is 20 divided by 2. That's actually the log of 10. Okay? And that's it. It's just, this day is all about re-expression. How do we rewrite things, either starting with addition, subtraction, multiplication, and working back to a single log, or starting with a single log and getting it written out in expanded form over here. Okay?